Okay, guys, now let's talk about the second transformation of this unit, and that's reflections. So a reflection is simply a flip across a line. And the two lines that we are going to be reflecting across is going to be the x-axis and the y-axis. So you can see in this example that triangle ABC is in quadrant 2 and it reflects across the y-axis and it lands in quadrant 1. Now, the line of reflection is the y-axis, but we can write this as an equation of x equals 0. So you need to know that these two, this equation and this name mean the same thing. The y-axis is where all your x coordinates are 0. Now, before we get moving on, I want you to notice the distance that A and A prime are from the line of reflection, and B prime, and then compare C and C prime. So the point is that the line of reflection, each point and its corresponding point are equally distant. So again, make sure that you have the line of reflections, the x-axis, y equals 0. So this is the x-axis, and this is where all your y coordinates are 0. So example, if we picked this ordered pair, this is -8, 0. If we were to pick this ordered pair on the x-axis, this is 5, 0. All of the coordinates on the x-axis, the y is 0. So that's when we have this equation y equals 0. And again, we've already discussed the y-axis. All of these coordinates, the x is 0. So for example, up here, this is 0, 8. This coordinate is 0, 6. This coordinate down here is 0, -9. All of these ordered pairs, the x is 0. So that's why we have the equation x equals 0. And again, make sure that you understand that each point of the pre-image and its image are the same distance away from that line of reflection. So here are the rules for the line of reflection, and they're pretty simple, pretty straightforward. So in this example, we have the blue triangle, and it is flipped across the x-axis, and so this is how we notate a reflection, lowercase r, and then it says x-axis, or it could say y equals 0. So when we flip this point of -4, 5 right here, and we flip this across, we are now at -4, -5. So as we flipped across the x-axis, notice that the x coordinates stayed the same, but the y coordinates changed to the opposite sign. Now let's take a look at when we reflect across the y-axis, which is x equals 0. This time we are flipping from the blue and we are going across the y-axis. So this time the y coordinates stayed the same, but the x coordinates are opposite in sign. So to sum this up, when you reflect across the x-axis, the x coordinates stay the same, the y changes to the opposite. So let me just share with you that this negative just means opposite of what the value was. It doesn't necessarily mean it's going to be negative. It just means you need to change that value to the opposite. If it was positive, it becomes negative. If it was negative, it becomes positive. So if it reflects across the x stays the same and the y changes to the opposite. If we reflect across the y coordinate stays the same and the x coordinate changes to its opposite. Okay, so let's take a look, and when they have asked us to write the rule, we see that this is a reflection, and we can see that it did reflect across the x-axis, which is y equals 0 or x-axis. And we are going to identify A is 1 comma negative 2, B is 1 comma negative 6, and C is 5 comma negative 6. Our A prime is 1 comma positive 2, 1 comma positive 6, and 5 comma positive 6. So we can see that this was reflected across the x-axis or y equals 0, but what if we did not have the graph and we just had the pre-image coordinates in the image? We could see that the x's remain the same and the y coordinates change to their opposite. So that means it reflected across the x-axis. Or our y equals 0. These are the same. Okay, let's take a look at one more example here. Our pre-image is the red one. We know it's the pre-image because there's no primes. So A is 3 comma 7, B is 3 comma 3, C is 5 comma 3. And now it reflected across the y axis. So this is the y axis or x equals 0. And we have landed in quadrant 2. So we went from quadrant 1 to quadrant 2. A prime is negative 3, 7. B prime is negative 3, 3. And C prime is negative 5, 3. So when the y coordinates stay the same and the x coordinates change to their opposite sign, it reflected across the y axis. Or we can say little r, x equals 0. Okay, this time we're just going to notate the pre-image. We see that it is reflected again across the x-axis or y equals 0. So we have negative 6, negative 4. We have negative 6, negative 7. And we have negative 2, negative 7. So we are in quadrant 3. We have reflected across the x-axis, and that means all of the x coordinates remain the same. So now that I identify this rule, it makes it very easy. So the x coordinates remain the same and the y coordinates change to their opposite. And these are the type of coordinates that we need in quadrant 2. Now let's just make sure. So we can see that from A to our line of reflection is 1, 2, 3, 4 units. And then from the line of reflection to A prime is 1, 2, 3, 4 units. So I'm just double checking that. So each point and its coordinate, its corresponding point, are equally distant from that line of reflection. So we reflected across the x-axis. Okay, so I think we're good with that one. So let's go ahead and go on to where they give us the pre-image, they give us the rule, and we reflect across the given axis. So first of all, A is negative 6, 5. B is negative 6, 3. And C is negative 2, 3. It reflects across the x-axis, so I always like to put in a dotted line of reflection. And we already know that if it's across the x-axis, then the x coordinates remain the same and the y coordinates change to the opposite. Now, we were in quadrant 2, and we are reflecting down to quadrant 3, which is our negative coordinates, and so we are correct. So we are going to plot negative 6, negative 5, and notate A prime. B prime is negative 6, negative 3, that's B prime, And C prime is -2, -3, C prime, and then connect to make your triangle. And they are equally distant from that line of reflection. Okay, let's do one more. And this time, our rule is to reflect across the y-axis. So I'm going to put in that line of reflection with a dotted line. And our pre-image coordinates, A is 7, 5, B is 7, 1, C is 5, 1. We are reflecting across the y-axis, which is also x equals 0. So when we reflect across the y, our y coordinates remain the same, and our x coordinates change to the opposite. And these coordinates, negative, positive, negative, positive, negative, positive, does put us from quadrant 1 to quadrant 2, where we know we would end up. So A prime is -7, 5, B prime is -7, 1, and C prime is -5, 1. And then let's connect those, and you can see that like 7 prime, excuse me, A prime is 7 units from that line of reflection, and point A is also 7 units. So they're equally distant. Okay, let's take a look at this one because we have one of the vertices is on the axis of the line of reflection. So here we have our line of reflection, the y axis, A is -1, -1. So our A prime is going to be 1, -1. Across the y stay the same. So this is 1, -1. Then we have B, which is -4, -5. Across the y remains the same, and our x changes to positive. So we have 4, -5. And then C is 0, -5. And a 0 is neither positive or negative, so it just remains the same. So C and C prime are the same ordered pair. And that does make sense if each vertex is equally distant from the line of reflection. So C and C prime are 0 units away from our y-axis. Okay, so now let's not use a graph. You can use it if you need it. So 5, -3 is in quadrant 4. So that's down here. We are reflecting across the x-axis, so the x remains the same and the y changes to its opposite. So positive, positive is quadrant 1. So here's quadrant 1, positive, positive, quadrant 2, negative, positive, quadrant 3, negative, negative, and quadrant 4, we have positive, negative. So y is negative, positive, so that is in quadrant 2. It reflects across the y-axis, so that coordinate stays the same, and our -5 changes to a +5, putting us in quadrant 1. So we went from quadrant 2 to quadrant 1 across the y-axis. Z is in quadrant 3, where all the negatives are. We're reflecting across the x-axis, so we're going to flip up to quadrant 2. So our x coordinates stay the same, and our y's change to the opposite. So we're in quadrant 2. Okay, so I think that's good with those, and I hope this helps.